Hello, Dr. Fuad. My name is Samy, and I'm Paris Hong Guan, and today I'm going to show the Lab 2 demonstration video, and I'm doing the part of student 1. So for the first part, it is a very simple code, and then I have filled up the table of like the value of the register and the variable in which of the each line. So for the line 1 it is example. For line 2 we can see that mov px comma variation, variable 2 var 2, which means we put the variable 2 into bx, which is, and then the variable 2 content is 9 in decimal, which is 9d. And then line 3 is a xchg, which means exchange. It means to exchange x and bx the value. So as you can see, it's supposed to be 1 and 9, now it's 9 and 1 in hexadecimal. And then lastly is moving the value in the register into the variable, x to variable 1 and bx to variable 2. And then here's the, I'm going to show the actual code instead of the screenshot. So as if we will debug this by step over method. Okay, so now we will step over one by one. So starting from the first line, as you can see on the bottom left, at the first nothing happened yet for the x and bx, because that's what we're focusing. So after the move x bx, the one is a variable 1 is assigned to 1 to x, and the next one is variable 2 into bx, and then the exchange of value 1 9 is going to be 9 1. Next, see 9 1, and then now it's going to store into the variation 1 variant 2, which we can't see in the register, but it will happen since you see the EIP changing. That is all for the lab 1. Hello, Dr. Fuad. This is Samy doing the question 3. So I do find something a little bit problematic, not problematic, something maybe a mistake, maybe not. The question says that we are doing this arithmetic expression, which then the final value will be stored in the variable 4. However, the line does not do a code where they store the ex into variable 4, which is why I just put the variable 4 into 0, since it is question mark, and then the code doesn't use a variable 4. So let me show the coding. The code is exactly like the lab. So when I do the step over, so when the first line executed, it assigned the variable 1 into ex, which you can see here it's 5 decimal and 5 hexadecimal is the same. And then here you can see the variable 1, variable 2 value, which is, you can see over here, here it's the same. So for the next one, line 2, multiple variable 2 into with the value in ex, which in hexadecimal will equal to 32. And then for the next line, we add the value in ex into the variable 3, which is 20 decimal, which will be converted to 14 hexadecimal. And then lastly, DEC DEC ex means the code will decrement the ex by 1, which when you see it's 46 in ex now, and then when we step over it, it will become 45. And then since I mentioned the value should be stored in variable 4, but it doesn't have a code, so as you can see at the watch variable here, I put variable 4 and it's equal to 0, because we did not assign it to from the value of ex. So if we should assign it, then this value will equal to same with the EX. If not, it will remain 0. That's all for question 3. Hello Dr. Fuad, this is Samy doing question 5 of the lab 2. So this one is quite simple. You just give us the code snippet, and then we just need to add COALAB2 regs, and then the data like include Irvin. Like this is the code. So I'm just gonna run the step over debugging. So as you can see here, when we step over the first one, it just put the dx into 0, assign dx into 0, like as you can see here, the first 4 bit, and then the EIP here means it's follow the address here. It fetch which instruction, like which offset, maybe offset or address. They keep tracks of the address of the instruction. And then when I step over again, the next one should be assign AX with 1000 hexadecimal. So as you can see here, it's 1000, so it's 16-bit because it's 2 byte, 16-bit. And then for the CX, we assign 25 hexadecimal into CX, which should appear here. Yes, this is how it assigned. And then now we want to multiply CX, but it doesn't say multiply what, but how it works should be it's a multiply CX with the AX. So CX is here 25 and AX is here 1000, so it should be like 25000. But something interesting to mention is that it only shows 5000 because it's overflow, or maybe you call that carry flag, because the 25000, and then it is how many, 16 plus 1 2 3 4 5, so like how many is that? 1 2 3 4 16 plus 4 20 byte maybe. So because the AX only can accommodate like 16-bit, so the extra, not the extra, the remaining MS most significant bit MSB will be transferred to EDX, which is the 2 over here. So it should be like 0002 5000, so like it's 25,000 to be simple. And then EFL is red because there is some change value because of the overflow flag and the carrier flag, and also the parity flag, as you can see in the dumb regs. And then that is all for this code. This is the dumb reg, and then I'm gonna end this code. Okay, thank you.